Hello, welcome back to 14 Minesweeper variants. We're finally at the end. Well, it looks like the end, but we're nowhere near the end. But we're finally at the end of the very beginning. We're at the end of the beginning of the game, basically, at hashtag plus. So, after hashtag, which was it was a board with every clue being of a different type of a right side clue. Hashtag plus basically does that, but with an additional left side clue in place. Yeah, and so 14,000 is like 200 here. There's 1,400 here, as expected, because there's 7 right side variants. So there's 200 of each variant lined up for us. Okay, so it's basically the exact same thing, but with an extra rule combined. Yeah, and then you see we have a lot of stuff we can unlock from this. 10 levels of the the largest size gives us exclamation mark, which is right here. Exclamation mark is the harder version of harder puzzles. It's basically identical to this setup though, but it's just a bunch of harder puzzles. So we'll see how that goes. Okay. Then we have, what else do we have? 3 levels to unlock the next size. 10 levels of this plus N8x8, which I already have. It will give me 2E and 2 hashtags, so 2 hashtag with a specific E involved, and same for L. Okay, I suppose we'll begin. So we'll assume that 2 hashtag is basically, you already know what 2 hashtag means, and then you also know what every other clue means. So I suppose I will just explain how the left side clue works here. Horizontal means all mines must have a mine adjacent to it horizontally. So mines that are isolated horizontally like this are not allowed. We can do that very simple deduction here where this can't be a mine because it would otherwise be isolated. Can you use cyan here? Yeah, cyan's a nice color here. So that can't be a mine basically. Now A as a value can only be a 2 at maximum, and also those can't be mines. Same here, this AD means those can't be mines. D now can be 2 at maximum. C is an area. You can see here, 1 modulo. Sorry. Oh, we can do horizontal, right? I kept forgetting horizontal is still in play here. So that's not a mine, that's not a mine. 1 modulo plus 1 modulo. Well, we can use modular arithmetic here. This box over here has a number of mines congruent to 1 mod 3. Therefore, this plus this box over here must have a value congruent to 1 mod 3 as well by this clue. And because they sum to a value of 1 mod 3 and this is 1 mod 3, then this must be 0 mod 3. And the only way that works is that this wasn't a mine. Therefore, C is now 0. A and D are 1 and 2 each. And we know that because nothing else can be 1 and 2. Therefore, they sum to a total of 3. And because they sum to a total of 3, well then all 3 of these have to be mines. A, well we don't know yet. I'll say A could be 1 or 2 still. Okay. By horizontal, these are both mines. And therefore, because of 1 modulo, already sees 2 mines, it must see 2 more. 0 modulo, well, there's only 3 mines remaining. So this 0 modulo, well it sees 1, and it can't see something as high as 6. So it must see 3, it is essentially a 3. Oh, by horizontal this is a mine, so A is actually just 2. And then D is 1. Now there's 2 mines remaining, and because of this 3, which is this 0 modulo, which is a 3, there's 2 mines here. That would complete the entire puzzle's mine count. Whoa. That would complete the entire puzzle's mine count, which means that nothing else here is a mine. 0 modulo with 2 cells means that they have to both be empty, give you mines here and here. There you go. Nice. I left all the markings in here because it looks nice, I suppose. But yeah, that's not bad. I really enjoy having a left side clue in play because having only right side clues is a little boring. It's not really my style. I want something global, somewhat, just to make things a lot nicer. Alright, let's keep going. We have connected and liar. Now connected means that mines must be connected diagonally firstly, and secondly all regions of mines must be rectangular. Alright, two product just has to be these 2 mines, Reason is because root 2 is only 1 times 2, so those are both mines. Oh, I could. Oh yeah, I was gonna say lie means one of these could are lying or could be lying, but root 2 can't be lying, and the reason why is because 1 plus root 2 is definitely just not a possible product you can have. So there you go. For vanilla, no idea. Well, definitely could be 5, because if it were 5, it would really just break the connected rule. If it were 3, then this can't be a mine, because then these would be isolated. But if it were 4, this could in fact be a mine. If this was empty, then this can't be a 4, because once again that would break. So this would have to be a 3. Although again, we don't know where it would be. Okay, well, looking at this 2D, we can prove that there are some number of mines in this box. The reason is because 2 is at most a 1, at least a 1, sorry. And because at least a 1, there's at least 1 mine here. What does that mean about this 2D over here? Well, to get to this area, you have to have mines come from here, right? So you have to either go up through here or go up through here. But notice whichever way it does in fact go, suppose it went up this way, we have to take at least 1 mine from here, at least 1 mine from here, and then at least 1 more mine from here to even reach the top row. Therefore, this 2 is definitely lying and is therefore equal to 3. Nice. This 4V is, well, it can't be these two, so this can't be, so this has to be a mine. And therefore now, this being a mine, we already now know is wrong. Because if it were, again, we have to have a mine here and a mine here, and this 2 being a 3 is also not possible. So this can't be a mine. This must be a mine for it to connect outwards, therefore this has to be empty. 0 area means these are both empty. 1 vanilla, we don't know if it's lying or not. But I know by connected this can't be a mine because you form an L shape. So therefore one of these are mines. And I think I can erase this and this. Now once again, this can't be empty because whatever mines are here, we know there's at least 1. Would be isolated, so there's a mine there. Therefore, in this column, the lie has to be here. So 0 is modular. 0 modular is a liar. Very fascinating. How would 0 modulate? Well, 0 modular being a liar has to just be a 1 modular. Currently sees 2. So I'm gonna guess it's a 4 in total. Can't be as high as a 7, so it's a 4 probably. But can I figure out which? Well, I know there's at least 1 mine here, right? The reason why is because this mine needs to escape somehow. But there can't be 2 mines here, because then you would have a very non-rectangular L shape. So there has to be exactly 1 mine here. And because this 0 is actually a 1, there is exactly 1 mine here. What that means is that this 2D does in fact see 2 mines, therefore it is telling the truth. This is therefore a liar for the column. This is a liar for the row. This is a liar for the column. And we have everything. This must be a 2, so that's a mine. This 1 modulo is lying. But this could actually, no, this 1 vanilla tells us that this is a mine. Based on this 1 modular liar alone, this actually could be a mine or a non-mine, because then you get 0 or 2, both of which work. Anyway, this 1 vanilla means that it has to be a mine. I just realized we could have marked this off as non-mine because there's 2 deviation, which is a lie, but either way. This 1 vanilla is a lie, means that can't be a mine. Therefore that's a mine, therefore it's empty. We have 2 mines remaining, so those are both mines. Ta-da! Pretty sweet logic. Also, I like my drawings. Let's keep going. More encrypted. Well, B and D are both at most 1 each, therefore that already gives us a pair, which is quite useful. Root 2. Well, root 2... we don't know what root 2 can do yet. D area, D deviation. Ooh, okay. So... I do see a few ways this could work though. Deviation and area. If it was 0, well, it's very obviously just this. If it were 1, actually no. Because 0 and 1. Yeah, we only have two options here, so we might as well just work with both. If D was 0, then these are both empty. But if D is 1, then by this area, this has to be a mine, making this empty because of deviation. So this is always empty. CV. Not entirely sure. Or one modulo though. Yeah, because of this BD over here, we already know is 0 and 1. Then B and D will sum to 1 no matter what. Therefore, there's exactly one mine here no matter what. This one modulo, which now can't be anything higher than a 4, can't be a 4 or higher in fact, because it only sees 3 cells, can only be a 1. I'm seeing a 1 mine here, means this can't be a mine, giving us C to be at most a 3. In fact, C can't be a 3, because if C were a 3, you'd have a mine here and here. I'm ignoring these cells. Then I have to have a mine here and here, which breaks D. So C can't be 3, can't be 4 either, because it doesn't have enough mines around it. So C is exactly 2. Now A is at least 3, and yes, that is only possible if mines are here and here. So those are both mines, making A 3 and E 4. Yeah. So now what? I'm not entirely sure. This deviation? No. This deviation? No. I don't want to use something like the remaining minecart. I don't think we have to use that yet. We do know there's exactly one mine here and then at most one mine here, at most. Like this. I want to draw that, but even counting that, we'd still have 1, 2, 3, 4, 5, 6, 7 cells possible, which gives our total a value of at most a 10. But that's fine because we have 8 mines left, so. 2 vanilla, what does that do? It doesn't do much. 3 vanilla? No. The root 2 might be useful, but I don't think it does anything. No, it doesn't. What am I missing? Probably something to do with this, right? If this were a mine, then this is empty. But that's fine, that makes a lot of sense. If this were a mine, then this is empty. Which makes a lot of sense. And then they both work. I don't see what the issue is. I suppose in the blue case, in the cyan case, D is 0, giving you this. Right? But again, that doesn't really tell us much because we already calculated that that's also possible. You could then place mines in all of these cells to give you a total of, I think, 11, which is more than the mines you need. So, what about orange? What happens then? Well, then this DV is exactly a 1, but then that really doesn't do anything for us. So what can we do? Yeah, what can we do? Oh, I'm so dumb. It's this rule right there. Segment. I did not remember that we had an extra rule in place. See? Okay, there you go. So each row contains 1 consecutive segment of mines. So the extra rule here is that your mines can't exist as multiple segments in every row. It also can't exist as no segments in a row. So for example, you can't have no mines here, but you can't have mines split up like this either. So something like this fails because you have mines in separate segments in the row. So it must look like this. Alright, therefore that's empty. Therefore that's empty. And we can probably do something with this. I think this is always empty. The reason why is if this were a mine, then this would be empty, giving you this empty as a segment result. Whereas if this is empty, then D is 0, giving you this to be empty as a result. So that's empty. Okay. We could probably use mine count now. Okay, we have so many empty cells now. Yes, and how will we do that? Well, there's exactly 1 mine here. There's at most 1 mine here. And placing mines in the remaining 5 cells would give you at least a 7. Sorry, there's at least 1 mine here. And so working with a maximum here is the only way to get to 7. So that means there has to be mines here, 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 and here. There's at most one mine here, which means D is exactly 1, B is 0. Therefore, there is a mine there, no mine there. This route 2 means there has a mine there, and therefore it's empty. There you go. Very cool. Also very cool that we used the remaining mine count so early in, with 7 mines remaining. I do agree that really didn't use a lot of the clues. He used one of them at most, so sure. I guess that is acceptable for non-exclamation mark puzzles. Normally, this mine count stuff doesn't really happen much in the regular puzzles, except maybe like at the very end. Alright, let's keep going. Group and liar. Okay, well, I can definitely see if this was mine. This would be lying firstly, but those will all be empty. And then this would have to be isolated, which fails, so that can't be a mine. 5 product? Whoa. I mean, that has to be a lie, right? I'm guessing it's definitely a 2 times 2. Actually, that's not entirely true. You could have root 5 times root 5. Yeah, that's plausible. I don't get why this wouldn't be plausible. Then the 0 could also be telling the truth. But if this was lying, then it has to be a mine here, 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 or here. And I think this would definitely be lying. It would have to be a 4. But then, even then, it could see 1 times 4 or... or could it? Wherever you have a mine here, it's either a 1 times 4 or a 2 times 2 times 2 root 2. Either way, anything between 2 times 2 between 2 root 2 and root 2 would have to be non-mines. So all of these will be non-mines, and whatever mines are here will be isolated by group. So I think you can't have mines here, so 0 must be telling the truth, giving you empty cells all around. Now there can't be a mine here. In fact, this can't be telling the truth, because if there were a mine here, we have to extend out by group, and that would fail. So that means that this must be lying. Therefore, that's empty. So this 5 is telling the truth, which means it must be root 2 by root 2. Sorry, root 5 by root 5. Therefore, anything that's 2 away is not a mine either. 2 product is telling the truth though, so that's empty because it can't be root 2 times root 2. This can't be a mine by group. Therefore, this must be 1 by root 2, which means that must be a mine which must extend. This 2 deviation is definitely lying because you don't have enough cells. So it's just a 1, which means that's a mine, which means that must extend. Okay. This 5 is complete with 2 things that root 5 away. Well, now I could probably use group. There are 8 mines total, and group, well, because in group every mine must form a region of size 4. I don't think I explained that, but now you know. We can never reach this cell, with any of these regions. We know that's exactly 2 regions, and these are the 2 regions we are forming. To get to this, we have to use at least 5 cells from here and at least 5 cells from here. And so this can never be a mine. Can I draw this better? There you go. So this can't be a mine. The same thing goes for none of them. Everything else can actually be reached by these mines. However, now we know that this is however, now we know about this. We know this has to be a lie, definitely. Which means it's 2v, seeing already 2 mines. It must be a 3. So I don't see how any of this could work. I mean, I don't see how any of these could fail. However, I do notice that this can't be empty though, because if it were empty, this region will be forced to move down this way, breaking this 2 because it would then C4. So this must be a mine. It is entirely possible for this to be a mine though. So this would then be not mine. Oh, but now this is a mine, means a lie has to be here, and therefore the last lie is here. This is, well, it's a 1 plus root 2, but it's definitely just a regular root 2, which means it's 1 times root 2, giving you 1 region. 5 area is a 4. Well, that makes sense. So this this thing over here, yeah, is an area of 4. It must extend out though, we know that. And this 2 I'm telling the truth, but it only sees 4 mines, so it must see 1 more to get to 2 mod 3. So there you go. That is your puzzle. Hopefully placing the markings there doesn't obstruct anything. But yeah. Okay, let's keep going. More encrypted, huh? Okay. Oh, I don't want to skip the level. I think I'm just like trying to wipe some dust off my mouse. I'm sorry. Alright, there you go. We can see here that B and C, or B and C are definitely not 3, not 4, sorry. A is only up to 2. D could be 4 though. But D can't be 4 because if D were 4, then this one modulo would fail. So D can't be 4 means E has to be 4. In fact, there's exactly one mine here because of the one mod. I'm not entirely sure how to resolve that. C can't be 0. If C was 0, then all of these would be empty, making A 0, and that doesn't work. So C can't be 0. Oh, there's also I almost forgot there's an extra rule in play. Flowers. They're exactly one mine with 4 cells around, within the 4 cells around a colored cell mine. So if you had a mine here, then exactly one of the 4 cells around it are mines. Same for any colored cell. However, I think non-colored cells have zero restriction. Okay, now what? So what if C was 3? I think that might break. If C was 3, then these are all mines. Then you could only have one mine here for this thing, forcing you to have a mine here and here. I guess this has to be a mine as well. That does work though. This would have to be empty. Then so would all of these actually. Ah, and because of this cell and this cell, this will both be empty, breaking this. So C can't be 3. Can B be 3? If B was 3, C had to be 0, right? Yeah, and the reason why is if B was 3, then these all have to be mines. This would be empty, forcing C to be 0. So B can't be 3, meaning D is 3. And we already know there's one mine here, so the only way to fix that is to have 2 more mines here. By flower, these are all non-mines, giving you a mine there, which must extend out. And the reason why is because colored mines must have one non-colored mine around it, so that's a mine. 3C, well, 3 means that has to be a mine to make 3. So C is definitely just 2. This can't extend. Therefore, this A, we still don't know. This one modulo must be a 4 though, because it already sees 2. So A is 1 and B is 0. Meaning that's not a mine. In fact, these are both mines. What? Oh, it sees this. I didn't see that it saw that cell. Whoopsies. Okay, well, we can do the exact same thing. D is not 4, so E is 4. And C is not 1 or 3. In fact, B is not 3 either, so D is 3, meaning those are both mines, so those are all empty. Therefore, that's a mine which must extend out. This happens. This can't be a mine. These are both mines. A is 1, B is 0. So that's empty. There's exactly one mine here. This 2 already sees 2 of those, so that's empty, and therefore that's a mine. Therefore that's empty. 0 modulo seeing 2 so far means it must see 1 more to make 3. So one of those are mines, meaning that's empty. I'm sorry, there's 2 mines remaining, which means that it has to be a mine. Okay, well that was my bad. Let's do it one more time. Yeah, this can't be a mine, this can't be a mine, this can't be a mine. So that's a mine, those are both mines. Those are all empty. Therefore that happens, must extend out. This can't be a mine, therefore that happens, therefore that happens, therefore that happens, therefore that happens. Alright, so one of these are mines, meaning that has to be a mine. There you go. This also can't be a mine. The reason why is because if it were, this would be empty, and by flower this will be isolated. So the mine has to go there. Ta-da! Nice. Alright. Next. Liar again. 4 area. Bridge. Oh dear, bridge. Mine forms 2 chains from left to right, or 3 on 7x7s or larger, but right now we're going 5x5, so yes, it is in fact 2 chains. A chain is a group of mines that connect the board's left and right side by horizontally or diagonally connected mines. So you can see here you have 2 chains or 2 bridges, and they can touch each other, but they have to be either moving diagonally forward or horizontally forward. So things like disconnected bridges doesn't work. Bridges that must end in one area, and you can't have bridges that move upwards or downwards at all. So you can see there's definitely 10 mines remaining for 5 for each bridge. So you could have bridges that look very, very funky. But one thing you can't have is a bridge as mine here, because it can't extend out to continuous bridge, so that's empty. 0-2, if it were 10 to choose, it would have to do this, which gives you that, because this must extend out. Now this can't be a mine either for the exact same reason, and she can't go backwards as a bridge. So that's empty. 2 root 2 is definitely telling the truth because it can't be, it's a product, we already know that. But 2 root 2 is either 2 times root 2 or 1 times root 8. Can 1 times root 8 work? If it were 1 times root 8, actually it will either isolate it like this, or it will isolate it like this. So we know it can't be 1 times root 8, it must be 2 by root 2, so that happens and that's a mine. This must extend out backwards to form a bridge. These two products, well, we already know it's lying because it already sees things that are one way, so that's definitely a liar. This is 4 is telling the truth, therefore. Which means what? Well, this can't be empty because if it were, then your mines have to go here, here, and here, and you already have 3 whole bridges starting. So this has to be a mine. Which probably joins to this. I don't see how else it could do things. I mean, it could do this and this, but at that point, you'd have a mine here and here, and isn't that basically the same as having mines here and here? Yeah, that's why it doesn't really say anything about crossing mines, crossing bridges, because crossing bridges can just be rearranged. Like this thing here could technically be counted as a crossing bridge, but by rearranging what you consider to be which bridge, yeah, it actually does just fit. Anyway, this root 2 is definitely just lying because it can't be a 0-2 anymore. Therefore, that's a mine. This one, well, it can't reach here because then you have an area of 5. Could in fact reach here though, because then you have an area of 4. However, if you did reach here, then this mine will have to extend out to form a bridge, which will give you an area of 5. So this can't be a mine. 0-3. If it were telling the truth, I guess it does work. Then this has to be a mine here, but that's fine. And this could go up here. Fair enough. But if this were a mine though, I think that fails. Yeah, because now this will be forced to be a 1-2 because of the 4 area, and 1-2 is not a valid way to make this lie. So this can't be a mine. Meaning this must be a mine to complete your area of 4, and those are both empty. This must be part of the bridge that goes this way and this way. This must be a lie by the column. Therefore this telling the truth means that's a mine, so that's empty. That's definitely a lie, meaning that's a lie. 2 products being a lie means it must be a 1, so those are both mines, and therefore those are all the mines, so that's done. You do in fact have 2 bridges. Bridge number 1 goes like this. I drew that bridge very poorly. And bridge number 2 goes like this. There you go. So bridges can in fact touch each other. Doesn't really look like bridges at first, but yeah, you can definitely draw bridges. Alright, let's keep going. Triplet and encrypted. Triplet means that mines can't form 3 in a row horizontally or vertically. They can diagonally form 3 in a row though. The other restriction is non-mines can't form triples horizontally or vertically. So this isn't possible, but they can form diagonal rows of 3 obviously. So we can at least start putting mines here and here first because of the row of 3. This has to be a mine as well. So now E is at least 1, C is at least 1. B and E are, that means B is at most 3. Okay, what else can we do? I don't think E can be as high as a 3, because if E were 3, you basically have mines here, here, and here. So E can be 3. If E were 2, I don't know how that would help. If E were 1 though, but E can't be 1, because if E were 1, then this would have to happen, which gives you 3 in a row. So E has to be exactly 2 then. Another way you can think about it is, if E were 1, this would have a total sum of 2. And 2 as a clue in triplet is just not possible. Because considering the 3 by 3 around it, you have to have a mine here, here, and here at the very least. Otherwise, you'd have 1 column being non-mine. So this clue here can't be 2 or lower. Meaning that E can't be 1, E has to be 2. Now, what does that mean? Well, there's at least 1 mine here. In fact, there's exactly 1 mine here from this. There's also at least 1 mine here due to the 2 in the light cells. So C now can't be exactly 1. C must be touching something else. That's cool. That's fine and all. But C could touch both of them, I think. Yeah. Those could both be mines. There's 2B over here. Or B, could B be 0? Yeah, B could be 0, I think. If B was 0, it can't be 0 of the dark cells though, because you can form 3 in a row like this. So if B was 0, it would have to be 0 light cells and 2 dark cells. This would have to be a mine, and so would this by triplet, which wouldn't really do much for us. So that's fair. I guess B can't be a 3 now, because if B were a 3, then very clearly you'd have to have a mine here, 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 and here, and that breaks. So B can't be 3. So now B is 0 or 1 and C is 3 or 4. If B was 1, I think that would still be fine. Yeah, if B were 1, I think there's no real problem still. There's 2 area though, how would that work? Well, you can't have a mine here or there, because if you did, then these would both be empty for the 2 area and you get 3 in a row. Can I redo? I can't redo, whatever. Anyway, what that means is that your mine can extend this way. D deviation. Well, that means D is at least the 1 because it already sees that mine. And in fact, D must be greater than 1, because if D was only 1, then these would both be empty, giving you 3 in a row. In fact, that must be a mine, I just realized, so that's empty. And now C and D are 3 and 4, so A can't be 3 or 4. But A isn't even in the puzzle, so I guess it doesn't really matter. This must be a mine by triplet. You can start seeing a checkerboard pattern coming out here, because checkerboard patterns in mines are like the easiest way to get rid of triplets, since diagonal 3 in a rows are allowed. You also realize there's a larger mine count here. It used to be 10 for normal puzzles, but now it's up to 12. Because if it were 10, it's just really hard to fulfill your non-mine count. I think that's how it works. Anyway, okay, so let's consider C being a 3. No, let's consider this being non-mine. If this was a non-mine, then for the 2-2 clue here, this would be a mine, this would be a mine. C would then already see 5 area total, and that's just not possible. So this can't be empty, this has to be a mine. Therefore, there's exactly 1 mine here, although we wouldn't know which. If it were this, then I guess quite clearly it's just a 4. But it could also look like this, and then this would have to extend out, but that's also fine. This is also valid for D to force C to be equal to 3. Yeah. Would this fail again? Wouldn't really fail. I guess in both cases this is always empty, so we can do that. No? Oh, that's another way you could fulfill C equals 3. Huh. Alright. I didn't expect that to be a thing. Okay, so now we already know it's easy with a 2 definitely. We also proved that these are both non-mines, therefore these at least a 3. C can't be 1, therefore you have something that goes like this. I think this is where we ended off. That's a mine. And then this is empty. That's a mine. I think that's a mine. Yeah, kind of forgot. Anyway, that's also a mine. There's exactly 1 mine here, so we have no say on what happens there. Okay. Oh, D is at least. Wait, D already sees 2. But D could in fact be 4 if this happened. I don't know. I don't see anything. D could also be 3 much more easily. I think it might be time to look at this. Maybe this seeing a mine here might be useful, because this would be empty, that would be a mine, that would be empty, that would be a mine. C would then be 3, D would then be 4, meaning mine here and here, meaning empty there. Haven't figured out this 2B yet. One of these are mines, we don't know which. How many mines do we have left? There's 6 mines remaining, and we already have marked out 5. So there's 1 mine here, meaning that's empty. Meaning that must be a mine, meaning that would be empty. But this works, right? I don't think we break any of the rules. So this is one valid possibility. What about mine here? If mine was here, this would be empty. This would be empty. This would be a mine. I guess it's always a mine then. Yeah. Okay. Doesn't really help, but I guess it's good to have mines in place. This 2B, well, I guess the 2 definitely can't be referring to the light cells in this case, so we refer to the dark cells. So there's one mine here. I guess we'll always have to be one mine here, because by triplet, we already knew that has to exactly be one mine here, at least. Yeah, it can't be 0, because... Oh, yeah, because B... Alright, so what this means is that the 2 here must be referring to dark cells. Because if it referred to the light cells, it would fail. I think that was like a simple enough deduction. So B is referring to light cells here, but could still be 0 or 1. I think that would work in either case. Does it really tell us how much we can do? If this were a mine, then this would be empty. Empty. This could be a mine. That will work. If this were a mine, then this would be empty. This would be a mine. This therefore can't be a mine. I think that would be a mine. Is this always a mine in every case? Is this just a 3 in every case? I think it might just be a 3 in every case. Alright, fine, I'll take it. So that's a mine. Now this can't go down here. That's a mine. This one modulo sees 3 so far, so it must see 1 more. Therefore that's empty. This 2 is already complete, so that's empty. This 2A... there's 2 mines remaining. There's one here. That's definitely empty. Therefore, there's 1 mine here. The remaining mine must be there. So this B, well, B is definitely just a 1 in this case. A is 0, but we didn't need to know that. Therefore, this can't be a mine because if it were, it would reach out to an area of 4, so it's empty, and therefore that's a mine. Solve the puzzle. Very cool. I think that's gonna call it though. We did not work with one of the... Oh no, we did 7. Oh, perfect. Actually, yeah, perfect. We did one of every single left side variance. Okay, cool. That means I'll probably end of the video here. I'll see you guys next time. Hope you enjoyed it. Yeah, bye bye.